Hello, you are now entering the infinite void. Hang on tight. We cannot save you now.
Hello and welcome to the first episode of the Infinite Void podcast. I'm your host, Jacob.
And I'm your co-host, Matty. And today's topic is space debris. So, for this first episode, I wanted to sort of go with something that I was personally interested in and I've known for quite a while. So, space debris is something that I've known about for about 5-6 years now, and I've been sort of interested on the side. So the sort of things I've got lined up is I want to obviously look at what space debris is, why it's a problem, and there's a couple of events in particular that I want to sort of go through, which are quite interesting. And then, of course, looking at how we can actually deal with space debris. So, before I get into things, what do you sort of know about it? What is your sort of familiarity with it?
So I know that it's a problem, and I actually saw in an article, I think it was last week, they were talking about it. It's obviously going forward, it's going to be even more of an issue because it's not just small stuff, is it? I can imagine that it's large stuff too, and obviously with all the satellites and everything we're putting up as well, it could be a bit of an issue. But from what I understand, because I had a little bit of a check, there's a lot. I didn't actually realize how much small stuff there is floating around in space.
Yeah, there's really, really a lot. So, you mentioned sort of big and small things there.
Yeah.
Actually, maybe from my perspective, but from what I know of it, it is actually some of the smaller things that are more of a problem and is more of an issue.
I was going to say, because I saw something not that long ago where they were saying, like, even if it's the size of like a screw, it's traveling at like 17,000 miles an hour. And
even way smaller than a screw.
Yeah, and it's just going to destroy stuff.
Mm-hmm. Yeah, exactly. So at the larger end of stuff, you have things like defunct satellites, so satellites that have sort of gone past their mission lifetimes and they're just sort of doing their thing up there. Rocket boosters that have made it into orbit after their sort of mission has done its own thing and the rocket booster itself has gone to orbit. They're sort of at the larger end of things. But and according to the sort of numbers that I've got here, obviously they might be 100% exact, but just a sort of the scale of the problem, about 22,000 objects larger than 10 centimeters in size. So that's things which, as I said, rocket boosters, defunct satellites is 94% of that. So only 6% of large stuff in orbit is actual sort of operational satellites and missions. So, and that's just at the bigger end of things. The numbers that I got for smaller things is that NASA estimates are about 500,000 pieces between 1 and 10 centimeters, and then an additional 100 million pieces smaller than 1 centimeter in low Earth orbit. So it's a pretty massive deal.
I think when I was looking at, when I was doing my little bit of research on this, I think I saw as well that there's 23,000 things that are larger than 4 inches as well, and they varied in their orbits. This was something I didn't even realize as well. There's obviously low Earth orbits, and then there's ones that are more distant, and because you'd assume that like most of the stuff would kind of be in a similar place. Do you know what I mean?
Mm-hmm. Yeah,
but it's really going everywhere. And it's
well, space is a big big place. So, so actually, as I said, it is some of that smaller stuff that is a particular issue because it's very, very difficult to deal with, both in terms of tracking it. So I think sort of ground-based radar can track sort of things on the scale of millimeters. So maybe sort of 5 millimeter sort of scale. Below that, it's very, very difficult to track and very difficult to deal with. Sort of dealing it is something that I guess we'll come on to later. But
and it's obviously made of like different materials as well, so you're not just looking for like one thing.
Yeah, exactly. So obviously, if you're using ground-based radar, then the sort of the radar cross section of it is going to be a massive issue as well. But yeah, it's not even sort of what's the best way to say, physical things even. So at sort of smaller scale, yeah, you've got, nuts and bolts and bits of sort of fragmented spaceship body.
Yeah.
But you've even stuff like paint flecks, and I didn't even realise sort of particulates that you get from solid rocket boosters. Even stuff on that scale can cause quite significant damage
Yeah.
to spacecraft.
Yeah, that, to be fair, because obviously the process using it to get it up there is obviously going to pollute as well, isn't it? So it's not just when they like crash in the sea and then they retrieve it. It's everything that gets put up there and then gets flung around the planet.
Yeah. So yeah, a pretty interesting picture that I've got here in front of me. I'm sure people can find it online if they search for it. Is the Space Shuttle Endeavour in 2000. This is about half a centimetre sized sort of crater in its front windshield caused by a 0.2 millimetre sized paint fleck.
I think I've seen that photo actually. It looks bonkers because it looks like it's like a bullet, but it's not even
exactly
anything like that. Yeah.
And this is the windshield of a space shuttle is obviously going to be I presume is going to be an area that is predicted to have sort of impacts and stuff, so it's going to be reinforced and
exactly
sort of a bit better to deal with it than like a solar panel or an optical element on a satellite or something. So
yeah, totally.
I think it just goes to show the sort of this problem.
Yeah, I might be wrong here, but isn't that film Gravity? It's got space debris, isn't it? Is that what causes the accident? But
yeah, that's like at the extremes of what I mean. I guess it could happen. Hopefully, it doesn't. But that would be at the extremes of what would happen. So
yeah, because there was a lot of stuff that crashed into that, wasn't it? But but I liked how, because I don't really like that film. I don't think it's very good, but it was cool when they showed you like how it could happen, like the speeds that everything was going, and how it like it's not just once either. It's like it's constantly orbiting.
So yeah, I think you said earlier, low Earth orbit's about 17,000 miles an hour. So it's pretty quick.
Yeah, totally. It's crazy, really. I can imagine then it costs loads to repair the International Space Station with this kind of stuff, or is that pretty well? You'd say weathered, but there's no weather because it's orbiting in space. But like, I can imagine that they have to do the occasional repair and stuff there.
I'll be quite honest. I don't actually know about the actual cost of it. In terms of smaller stuff, like the paint flecks, the bits of propellant, those sorts of things, that will be hitting it all the time. And most craft, International Space Station being one of them, are equipped with a thing called the Whipple Shield. So the Whipple Shield is effectively a tinfoil kind of material. I think it's aluminium. It could be something like silica as well, but basically a tinfoil like material. And these things are moving so fast that when it hits it, it will just vaporize on impact. So the Whipple Shield is able to protect the actual more sensitive part of the system. Obviously, that's not sort of a practical solution for things like telescopes and solar panels where you can't sort of put a shield in front of it. But at least for telescopes, most of those are not positioned sort of in these very cluttered orbits.
That's actually crazy, because like I didn't know that the International Station had that. That's pretty cool. I thought it would have just had other things, but that makes sense because it's up there a long time, and it's in the low Earth orbit, isn't it? The International Space Station. Yeah, so it's going to be in all of that debris. But go on.
On the sort of bigger scale, I know they perform. I don't know the exact figures, maybe tens of maneuvers a year to sort of move out the way of other satellites, including defunct satellites. Because those orbits are quite cluttered with stuff now. And so that's obviously something that NASA has to take into account when sort of planning missions and stuff.
Yeah. Well, I actually saw that. I think the last time two satellites collided with each other was in 2009, and it was above Serbia.
Yeah, I've got exactly that thing in front of you now. That's one of the things that I wanted to come on and talk to you about. So
there you go.
Yeah. So what do you know about that?
Not a lot. I know that it's one of the only times it's happened. I know that it was between a Russian satellite and it was between a US communications satellite.
Mm-hmm.
I don't think that it caused any other problems, but it did. They did like just wreck each other's satellites, didn't they? And it was above Serbia.
Yeah. Mm-hmm. Yeah. So this collision was between Russian Cosmos 2251, which was a defunct, I believe, intelligence reconnaissance spy satellite sort of thing. Cosmos 2251, and then Iridium 33, which is an American communications system for satellites.
For people listening, defunct is when it's no longer in use, right?
Yeah, it does. Cool. So defunct is either its mission has come to an end and it's no longer being used, or something has gone wrong on it, so it has died effectively. But yeah, basically something that's it's junk, it's rubbish, it's just still up there.
Yeah.
But yeah, this collision is the only collision between two satellites to date. They collided at 10 kilometers a second relative speed, and this actually comes back to what you said about gravity in that film. I don't know if you remember how sort of thoroughly you watched it, but there wasn't just the first collision which caused the problem.
Yeah, it came back
the
around.
debris goes back round.
Yeah.
Exactly. So that is actually one of the bigger problems with space debris. It's called this Kessler syndrome.
Yeah.
So Kessler syndrome being this cascade effect that one sort of collision can release more debris, which causes more problems than the debris was there to begin with.
Yeah, and it just keeps collecting as it's going round and round, kind of thing. Yeah.
Yeah, but also, as things collide, you get a sort of, if you sort of throw some paint against the wall, it all splatters out. You get that effect with these satellites. So they're on obviously two orbits, but once they collide, they sort of spread out over the next sort of hours and days to create more of a cloud of debris.
Yeah.
And in the case of Iridium Cosmos, this incident, it was on a orbit that does cross the International Space Station. And I know they have had to take some sort of, I think they slightly repositioned to a different orbit to get around most of this stuff. But it's pretty.
This stuff's still floating up there, right? Some of it
will be there. Yeah. It will be there for. See if I've got any sorts of figures. Usually, you would expect this stuff stays for decades.
Yeah.
Which is obviously an issue. Things like the American Vanguard, which was launched, over 50 years ago, is still up there in orbit. So it is quite a sort of big issue. This problem.
Well, it doesn't like get weathered, does it? Because
no, exactly.
There's obviously no atmosphere, so it just literally lasts forever until.
Well, at low Earth orbit, there is a very small amount of drag, so things will come down eventually.
Yeah.
But it's not a practical solution to the problem. Just to wait for it to stop. Really.
And it's not very good of us as humans to just let future generations figure that one out.
Oh yeah, another film that scene in Wall-E when they're taking off from the planet and he goes through that sort of big cloud of stuff in space.
The junk cloud.
Yeah, exactly. So, so there is this sort of ethical viewpoint of, space is meant to be something that everyone can enjoy in some way, and is I think it's referred to as the common heritage of mankind, sort of like the Antarctic and stuff.
Yeah. But
on the more practical level, space is becoming commercialized.
Especially with Starlink.
So that there is a sort of issue of if people are going to be investing a lot of money into satellites and sort of projects in space, there is a certain acceptable risk that they're willing to take, and if things get much worse, then that risk becomes non-favorable, as it were.
Yeah. Well, it's only going to get worse, isn't it? Because you've got like Starlink, you've got OneWeb that are doing their thing for the UK, and then there are so many other ones as well. It's just like, but I don't know. Where do you stand on that? Are you, because I see a lot of articles where people like astronomers and stuff are like, "Oh, this is really annoying. You're wrecking my astrophotography," and I get that because that is annoying. But like, I don't know. I feel like when it does come out, it's pretty cool that you can get like 100 megabyte internet connection anywhere on planet Earth. Like, it's good for like innovation and like leveling up third world countries, but I guess it does wreck the night sky, and there's only ever going to be more of them put up.
Yeah, so I think things like Starlink is probably an episode in itself that we'll come back to at some point, I imagine. But yeah, my view on it is, I think the astronomy side of it is unfortunate.
Yeah.
I think something probably does need to be done about that. But from a space debris sort of point of view, it has the potential to be sort of disastrous.
Yeah.
As I said at the sort of start, we're looking at sort of 20, 30,000 objects in space at the moment. Starlink's, do you know the sort of size of the constellation for Starlink?
I know that I was reading the one that they put up yesterday. I've got it here on my thing. If I can find it, which I can't, which is very helpful. But they chuck up a couple of thousand a time, don't they?
Yeah. In my head, I had 40,000 satellites.
Yeah, I thought it was 40 or 60, to be fair.
Which, that's sort of 2-3 times more, as many satellites as there have been released in the last 50 years, sort of thing. So from a space debris perspective, that has the potential to be really, really significant.
Yeah. And there's so many of them, and they're not clumped together either, are they? It's like in a netting formation around the planet. So it's like so many opportunities for it to get hit. It's not like the International Space Station where there's one thing that has to maneuver out of something. There are, like, as you said, tens of thousands.
Yeah. So I've got a graph here. I think it was produced by a UN department, but essentially it's tracking sort of the expected number of cumulative number of major collisions in space against years, sort of thing. And it's given 3 sort of case scenarios. So case C is no future launches, and with that they expect by the year 2050 there to have been about 5 major incidents in total. B is what they call business as usual. This was produced a number of years back, so this would have been sort of 2005, 2010 levels of launches. For the next 20 years, then no more launches, which is obviously not going to happen. By 2050, you're looking at 10 to 15 sort of major things. And then case A looks pretty horrific, is business as usual, again, before sort of Starlink and things were announced. And this is a rapidly upwardly curving graph. And about 2050, you're looking at about 30, 40 major collisions in total. So this is a real problem, to be honest.
Yeah, I mean, no wonder everybody's rushing to get their stuff up now.
Yeah, exactly. But the other event that I wanted to talk about was actually a missile test. So this was back in 2007. China launched an anti-satellite missile on one of their own satellites just to test it on the Fengyun 1C satellite, and just to test their sort of anti-satellite capability, blew it up effectively. And this was a really big turning point. This produced a significant amount of debris.
Then it's got a trajectory, hasn't it, after they've blown it up? Yeah, I wasn't even thinking because it's in that orbit. Yeah. So the estimates were about 35,000 pieces of debris over 1 centimetre in size, which would make it about 5 to 10% of all debris in space from this one incident.
Yeah, so this was not good.
Yeah.
But yeah, it's this sort of idea of who is responsible for this sort of thing, you know?
Yeah. There almost has to be kind of like a world treaty, but
Mhm.
you're always going to get countries putting stuff up that they're not telling people about and stuff because of like classified information and everything too.
Yeah, exactly. So there is a treaty on space, but it's quite lacking in this sort of area, to be honest.
Yeah.
There are, I think, sort of clauses now that new satellites that are launched have to be put in what's called a graveyard orbit,
Yeah.
or can be moved to a graveyard orbit. So they go up there, do their mission, and then either they naturally decay into an orbit that causes them to burn up when they re-enter, or they have sufficient fuel that they are pushed into a graveyard orbit.
Yeah.
There is this sort of removal of new satellites, but even, as I said, with these graphs that I sort of looked at earlier, even if no new satellites are launched, which is obviously not the case, the number of incidents is going to keep increasing because of this Kessler syndrome, cascade effect. Yeah, and you said about the sort of international treaty and I guess sort of international cooperation on the issue.
Yeah.
One of the big problems with this is that one of the topics I want to come on to in a bit is sort of looking at ways that this can be dealt with.
Yeah.
Sort of technological solutions.
Yeah. That's why I wasn't jumping the gun and asking the question yet.
We get onto that.
Yeah.
But the problem is whatever these solutions are, let's just imagine Russia got a capability to remove satellites from orbit, these defunct satellites, they can take them out in whatever way. That doesn't sound particularly great when it reaches the headlines of the New York Times.
Yeah.
Russia developed system to remove satellites. So this is sort of another sort of issue with this is countries ultimately have jurisdiction. They own their satellites even when they are dead.
Yeah.
So it's not simply a case of going up there and just sweeping everything up, because there will be political issues and even legal issues. Companies insure their satellites as sort of property for significant amounts. So that's another thing too.
Yeah, because then you've also got like countries that have different amounts up in space as well. And if everybody turns around and they're like, right, this is the new treaty, we're not doing this, or this is the certain limit that you've got. Countries like America and like Russia and stuff that have got hundreds of satellites up, and then there are like some nations that have barely any, and have to like abide by the new rules. And obviously, that's not fair either.
No, yeah, a country like India that's just sort of getting into the space game, it would be unfair to say, oh, you have to do all that. You can only have these 3 or 4 satellites while we have these hundreds already operational, sort of thing. So,
yeah, totally. And then you've got like even just corporations in America that have satellites, and then you're telling nations that they can't have them.
Yeah, exactly. So yeah, this sort of legal and sort of political aspect of it is also challenging and interesting itself to consider, I guess. Yeah,
must make it a lot more messy as a subject to try and solve, because then it's not just about like, right, how can we science to fix this? Because there'll be different nations as well that'll have different views on what we should do about it too.
Yeah, exactly. Yeah, that's so. It's not an easy sort of thing to solve by any means, but I guess sort of one of the reasons that I wanted to sort of make this episode was that it's something that I sort of know a little bit about, and it's something that I think does need to be spoken about a bit more. I'm not going to say it's the world-ending sort of climate change or anything like that, but it is an issue when you think about while we're doing this, even this podcast, there'll be sort of satellites that are doing things for us and
beaming it around.
Yeah, exactly. And I use my phone, get GPS for sort of when I'm driving around and things. So it is a sort of major aspect of our lives now, and it's a resource that is finite. There is only so many orbits and so much sort of space. Even though space is massive, it isn't infinite. In a useful way for us. So so it's definitely something to consider.
Totally, and it's one of those things as well where, like you said, it's not like climate change, but it also kind of is, because you're still looking at the idea of, if we don't start talking about this and resolving this, like, the future's going to be very bleak for space endeavor, and that is the future. So whilst we're wrecking our own planet, we shouldn't probably be wrecking our way to get off the planet too.
Yeah, exactly.
Imagine that, we put all our eggs in one basket and we destroy the climate, and then we can't even leave our orbit because there's too much junk.
Yeah. I guess like climate change, it's sort of an issue that's going to require international cooperation, and sort of, this is not something that maybe the Elon Musk of the world could solve, but in reality it's going to be an international thing that needs to be sorted out.
Well, as well, I was going to say, because they're developing all those new satellites as well, aren't they, for like monitoring coastlines and solar potentials and stuff, in even in the UK. So
yeah,
it's funny because, like, we're just making that problem worse by trying to solve this problem.
Yeah. But yeah, it's just that, you know, these satellites in either commercial use or in scientific uses are just sort of so fundamental now that we sort of need to act on this, I think, sooner rather than later.
Yeah, because that was actually something I learned not that long ago. I was under the impression that there was like one GPS system, but there's actually like 5, isn't there? There's like America has one, and then like China has one, and Russia has one, and I think Europe have one, don't they?
So Europe's is the Galileo system, which is being developed now. But yeah, there's Russia and Chinese ones. They're quite well developed already. So yeah.
And then you've got OneWeb's trying to do that, isn't it? Aren't they doing internet and GPS?
Well, so OneWeb has been acquired or is cooperating with the UK government on its GPS. On its, GPS is the American system, but we're calling it GPS as a simplicity on the UK GPS now that we're not a part of the Galileo system. But
I won't say the word on this podcast, but you know why.
that word is banned. But no one really seems to know how it or if it will work, because these OneWeb satellites are designed for internet applications, so have completely different frequency bands to GPS. So I guess that'll be something that we'll see in the future.
It'll be if it doesn't work, that's a massive amount of pollution to the space debris problem, as you're saying, because OneWeb want to put up like thousands, don't they?
Yeah.
So
yeah,
it's not good, really, because it's hard for people to imagine as well, because like you don't really see it. But it blew my mind. A couple of weeks ago, I went to like mid Wales, and we were like chilling on the side of a mountain, and we were just looking up at the sky all night. And I hadn't seen Starlink before this, and it blew my mind. Like, it literally blew my mind, because I was just sitting there watching the stars, and then all of a sudden I was like, whoa, there's like a line of stars. And I quickly realized, oh, okay, that's Starlink moving. And then there was just hundreds of them. And I was just sitting there, and I was like, oh my God, it's like, I'd be so annoyed if I'd, like, even just like on the ground level, when you hear people like astronomers and stuff complaining about it, like, it's annoying, and it's only going to get worse too. Because it's not just, it's like you said, it's not just like a visual problem for astronomers. It has like major implications for equipment, technology, and satellites, and all of that stuff.
Yeah, it's a massive problem. But I guess we'll be a bit more optimistic about and look at actually how we can deal with this. Some of the sort of solutions that have been put out about this. So have you come across sort of any solutions while you've been sort of looking into it?
So I saw something. I haven't really looked into it recently, but I saw something, I think maybe around Christmas, where there was somebody talking about, it wasn't, it sounds silly if I say net, but it wasn't a net. It was like a magnet thing that they were going to try and do and collect like the little things. Obviously nothing too big, but I saw something about that, but I'm probably wrong.
Yeah. So the sort of, from what I've read, there seems to be sort of three categories of sort of ways to remove debris. So one is sort of air resistance based approaches. So that can either be natural, putting it into an orbit where air resistance brings it down, and it burns up. So some sort of satellites now are they're sort of developing these things called solar sails. Where they will sort of catch the sunlight, and that will they will deploy them at the end of their mission, and then they will be pushed by the sun into sort of an orbit to decay.
That's what the Planetary Society is doing that as well, aren't they? They're trying to build a solar sail to blast something really fast at Alpha Centauri. Yeah. So using those to actually sort of push something back to the Earth, so it decays. But yeah, these sort of air resistance ones, they seem like the simplest things. You're essentially just increasing drag in some way to cause the spacecraft to deorbit. Obviously, that doesn't address satellites that are already up there, unless you go to some really complex engineering and attach these sails to existing satellites. But that doesn't seem like an immensely practical solution. But in terms of going forwards, this could be something that is perhaps part of an international treaty that new satellites must have these sort of these sails on them, or to bring them down. Yeah, I think that's cool. I'd rate that.
So that's sort of one solution. The second solution is using lasers, ground-based lasers. So for this, it's not quite Star Wars. You're not blasting them out of the sky. But all it is that, I say all it is, it's still impressive, is you use these really like high-power lasers. You point them at the sort of satellite as it comes over, and you use the laser itself to slow it down. So kind of like similar way to a solar sail, using light to push something, but instead you're just slowing the satellite down so that it deorbits, and that's done. This is relatively straightforward for larger objects. So things like rocket boosters, defunct satellites, these could be relatively easily deorbited using lasers.
Just can't get the small stuff.
Yeah, exactly. It's quite difficult to use on smaller things. And also the larger things are, so the really big stuff, it would take a long time, because obviously their mass means that you need a more sort of force to slow them down. So you'd be looking at multiple days and weeks sort of focused on one thing as it comes over every sort of
every
time that you could see it, sort of thing. But it's relatively simple, and it's quite cheap compared to the last thing, which is what you sort of said about, which is I guess you would call in a general term sort of capture techniques. So actually going up there and using, I've seen nets, something called Clean Space 1 was a project, using a sort of grapple to actually take it down, and sort of grip onto a sort of satellite or a bit of junk. So nets, grapples, these sorts of things, again, can deal with larger sorts of things. I've seen, it's a bit of a weird one, it's called EDDI, Electrodynamic Debris Eliminator, and it was a sort of big conductive tape that measured kilometers in length, and I think it would use some sort of electrostatic force to basically just hoover up bits of paint and stuff, in a bit like a electrostatic balloon would pick up hairs and stuff. But this sort of multiple kilometer long electronic thing just hoovering up things. There are some, as there are some mad things out there that people are planning to sort of tackle this issue.
Yeah.
Some seem more feasible than others, but yeah.
Yeah, totally. You almost want like a giant kind of like what they've done, really, to be fair. You just either want something that has got like an electric charge to it, so it can like collect those things by like creating static electricity, or just like, I was going to say you could get a giant net, but then you're going to have to move everything else out of the way. But I can imagine, I can't really, I don't know. It's a hard one to solve, isn't it? Because it's like you said, the laser thing's cool, but it's not really going to work on small things. And it's hard to even track the small things.
Yeah.
So I feel like you kind of have to do like collateral with it. Instead of like trying to track all of the little bits, you kind of just need to be up there and collecting it all.
Yeah, so the issue with these sort of capture techniques, so advantages are they can take down a lot of stuff and can be quite targeted, and sort of those advantages are good, are better than the sort of laser and air resistant techniques. The issue is obviously they're expensive because you've got to launch something.
Yeah.
In the case of grapples and nets, you're only taking down sorts of one-off items. So you go up, capture sort of one thing, and then deorbit it, and that's that satellite done.
Yeah.
And the other issue is it's the most complex and has the most danger for subsequent issues. If you launch a sort of grapple, it accidentally crashes into the side of your satellites, and then there's more debris, and then that's, if you're sort of launching something that's a few kilometers long, you can quite easily imagine a sort of satellite flying through that accidentally and getting caught up in it, and
yeah, totally.
more issues than maybe it solves. But there's some really weird sort of solutions to this out there, and some quite interesting ones as well.
Yeah, because I was going to say, you can't even really just have ones that like just decay or like fall apart, because it's obviously in space too. Because I was just thinking that, why don't you just make like a, as being a millennial then, I was like, biodegradable satellites, that's the future. But I was like, it doesn't really need to be. That makes no sense, kind of thing. But yeah, how do you solve it?
It's got to be, from my point of view at least, it's got to be some sort of active removal. It's not going to be good enough now just to let things sort of fall out of the sky by themselves in that way. So something does need to be done in one way or another, and I guess we'll see where that goes over the next few years.
I can imagine,
particularly as sort of things like Starlink sort of launch, where we have thousands of satellites. It's going to become a bigger issue.
I feel like this is definitely something for AI. I feel like managing and tracking space debris. I feel like that would be a good thing for AI.
Yeah, potentially. As I said, I haven't seen many.
Yeah, I was going to say, I don't think I've seen any AI like.
No. I don't think I've seen many developments sort of beyond the sort of solutions I just said about in the last couple of years at all, to be honest. So there's definitely a market for new technologies to move into this sort of area and see what they can do.
Can you hear my cat? Sorry, she's meowing outside the door.
I couldn't. I wish I could. That's
wicked. That's good then. I thought she was coming through then, so I was like, great. Luna's made an appearance on the first episode. But no, yeah, I feel like that's probably the way it's going to go, right? With like machine learning and especially for tracking, I feel like
exactly.
We probably need something. I'm surprised no one's doing that actually.
But again, it's who funds it, who pays for it, sort of thing,
Yeah.
Because I think NASA has a they have a tracking system. They track all objects using ground-based radar over a certain size, but how useful that is in terms of removal, I don't know. Particularly when, as I said, these smaller objects are potentially a bigger issue than the big trackable objects. So
Yeah. I don't know how reckless this is as an idea, but maybe this is actually probably really reckless, because then it's not solving the problem, it's just putting the rubbish somewhere else. But I was going to say, maybe like when it comes to the end of its mission, we just push it out of orbit and let it float off.
That's
but
from what I understand, moving something to a much higher orbit so that it flies off somewhere takes a lot of energy, a lot of fuel.
Yeah, and I was just thinking as well, contamination and stuff too, because obviously it's just going to float, isn't it, through space until it gets swept up by something else's gravity, and then that's not really fair either if we go and start wrecking the moon and everything. But that's going to be a new thing too, right, with satellites orbiting the moon and on Mars.
We'll have this whole issue again.
I feel like we should probably solve it before we become multiplanetary.
But yeah, I think the sort of standard is to instead of pushing it out, push it in, so it deorbits and burns up, which is tremendously safe. So there's not really any issues of stuff crashing on people and that. So
maybe that is the way forward to go. Have it so it's like made of stuff as well that maybe isn't, because I can imagine even when they burn up, that's a pollution problem as well, right? Just for us in general.
Potentially.
God, we're going to need like safe satellites made out of like materials that don't pollute when they burn up.
Yeah, there's definitely a lot to be done in this sort of field. And
I was going to say, we're definitely running before we're walking.
Yeah,
when it comes to certain things.
Well, hopefully through this podcast, maybe one person out there will be inspired and come up with the next massively successful technology that
solves it all.
See. So I think that's about all I've got to say on sort of space debris and stuff, at least for this time. Unless there's anything else that you wanted to
I was just
finish up with.
I was just quickly looking through my notes then, and I couldn't really see anything else. Just for anybody listening at home that doesn't really like understand the distances, this is actually something that I found. So most of the debris sits 1,250 miles above the Earth's surface, and it orbits in that area, which is home to a lot of satellites, according to NASA. Yeah. So,
wow, it's quite obvious that a lot of the debris is going to be where a lot of the satellites are.
Yeah.
So, but yeah.
But yeah, should we move on to what's been going on this week?
Yeah, let's do that.
Check out some news. So, if you want, I'll bring up my two things first. So, the first thing I've got, if my document will open. So, the first thing that I've got is the Ligo Detection. For anybody that doesn't know what's happened, basically, the LIGO, is it laboratory or an institute?
Let's go institute.
Cool. So they're basically like monitoring gravity waves, aren't they? From what I've seen, and they found the gravity waves of two black holes merging together from over 7 billion years ago, which is pretty cool. I saw the Guardian were talking about it. They were the good old headline of "It sounds like a thud," and they were saying it was the biggest like noise that we've heard since the Big Bang.
Yeah,
which is kind of cool.
Yeah, so there was something special about this one, wasn't it? Was it the size of the black holes, or
yes,
the distance, or
yes? I think it. If I can find the thing here, yeah. It well, the energy it created, like the gravitational waves, were equal to the energy of 8 of our suns. And from what I saw in MIT, I think they were saying that it's unheard of for the size of the supermassive black hole that it created. They thought that they could only get to a certain size, but when these two collided, it was like I think it was 142 times bigger than any other black hole that we found. And it basically kind of sets the new limit to how big we thought they could get, because maybe the end of the universe is just supermassive black holes until they radiate away. I don't know. But I thought that was cool. It's funny because I watched a documentary at Christmas when they were talking about LIGO, and like they made it look really poetic, because they were like, when these gravitational waves happened from these two black holes colliding, humanity wasn't even here, and then it showed like the whole human history, and then Einstein was born, and then he like theorized them, and then they built this machine and they found it, and they were like trying to make it really poetic, and I was just like, I don't know, I feel like we were gonna get there. Do you know what I mean? We weren't. It doesn't need to be as beautiful as it is, but it's awesome. I think it's class that there are ripples in our space-time, and we've got a machine doing it, because it's distance as well, isn't it? Isn't one in California and then one like 12 miles away or something?
No, it's more than that. I thought one was in Washington, and then one was down in Virginia or something. But it's hundreds, if not 1,000 plus miles away.
And the smallest thing can like trigger it, can't it? It's very, very sensitive, because they can't have like any electromagnetic stuff, can they, in that area for it? Yeah.
So I watched I think it might have been someone like Physics Girl on YouTube or something, did a really interesting video on this. The precision that these things have, because each of the sort of arms on this, I think about 1.5 kilometers long.
Yeah.
So essentially what these machines are is interferometers. So interferometers, you have two sort of beams, you recombine them. If sort of anyone knows about this area at all, you recombine these beams and look at the sort of coherence between them. So as the beams stretch and sort of squeeze, you get a sort of difference in the coherence as they recombine. And I think they said they were sort of measuring these things. They were sort of measuring distances in these 1.5 kilometer arms of this interferometer to less than the distance of the size of a proton. I think they said it's something like, you're trying to measure the size of, was it the galaxy or the observable universe? No, I think it was like our galaxy to sort of the hair's width. It was mental. This sort of, like the precision that you have. It really is crazy, LIGO.
Yeah, I was gonna say, I was just looking here. It was saying that the interferometer in America is 4 kilometers, and then
4 kilometers.
Yeah, and then the Virgo one in Italy is 3. And we're both wrong. It's not a laboratory or an institute. It's an observatory. That's why it's LIGO.
Okay. Oh yeah.
So there we go. But it's saying here that it happened on May the 21st last year, but they've only just managed to properly get through the data. And the estimated mass for the new black hole is between 100 and 1,000 times our sun.
Wow. That's big, isn't it?
And our sun's pretty big, but it's not even that big in comparisons to other suns, but it's big compared to what we know.
So just for anyone listening that's interested in this, just so you're aware, we're sort of recording a few podcasts at the moment, sort of in advance. So this news story and the other news stories are from the week beginning, the 31st of August, that sort of area. So this is from the 2nd of September, this news story broke. Massively interesting.
We'll probably be a week ahead in the news sometimes, depending on schedule, but hopefully it's not too bad for you guys, whoever's listening. Shout out if you are listening to our first episode, and welcome. But no, it seemed pretty cool. I thought that was a pretty interesting news topic. And then the only other thing that I've got was the SN6 hop that happened yesterday for the Starship missions. I'll just load that up now. For some reason, my computer is being slow, but it's probably because there's so much going on it. But so the Starship SN6 conducted their 150-meter hop test on Thursday, which was yesterday for us filming. And it was only come literally a couple of weeks after the SN5, which is fast. You know how Elon likes to have many prototypes going. But I don't know. I don't know if have you watched the videos because they're awesome.
I've not watched this one, but I've watched some of the previous ones. But
For anyone that
yeah,
doesn't know what it looks like, imagine like a silo that's literally hopping 150 meters with, is it a Draco engine?
I believe so. Yes.
With their Draco engine. It's super. Oh wait, oh no, yeah, it is a Draco engine for the super heavy booster. But it's awesome. It's pretty cool. I don't know. Are they? I think
Yes.
they're doing a few, aren't they?
Mm-hmm. So yeah, so this is the sort of craft that SpaceX developed. Elon Musk he wants to try and get us to the moon or Mars in it.
It's both, I think, isn't it?
Yeah.
Yeah.
So this is his sort of interplanetary vehicle that they're sort of working towards.
Yeah. It looks cool. I don't know if have you seen some of the renders with like the different uses for it?
Yeah.
It's awesome. That one where they've got the interior version where they've got that violinist playing as well, where she's like
Yeah.
floating with no gravity, just playing a violin to that crowd. It's crazy.
Yeah. But yeah, this has been a really sort of busy week for launches,
Oh yes.
hasn't it? Because there was the other SpaceX launches as well going on.
Yeah.
For that was Starlink, wasn't it? I think. Yeah.
Yeah, you had the Starlink launch, you had the SOCOM launch or something. SAOCOM launch, I think that happened. There was like 5 in one day, wasn't there? But 3 got scrubbed, which is quite fitting for the title of this episode. But yeah, you had a Starlink launch, you had a Rocket Lab launch.
Yeah, and that conveniently brings me on to one of my news stories that I wanted to talk about. Look at this, we're slick, aren't we?
Super slick.
Yeah, so this Rocket Lab launch was quite a special one for Rocket Lab because they launched their first Photon satellite. And this is quite interesting because this satellite is developed by Rocket Lab. So it takes Rocket Lab from just being a launch company to be more of a sort of full works type of company in terms of their capability in space.
They didn't let anybody know either, did they, till after they got it?
No, it was very... I think most people found out about it retrospectively. So
yeah, because I saw some videos that the CEO put up on Twitter, and it looked really cool. He had it just floating, and they were talking about what they were going to do with it, and everybody was kind of surprised because they were suggesting it, weren't they, by the way that it looked, but they weren't sure because it wasn't in the statement or anything, was it? I don't think.
No. So it was launched with the they call it the kick stage of Capella's Space Sequoia's radar imaging satellite. So it was sort of launched as part of that mission. And when that sort of satellite went off and was placed into its orbit, this Photon satellite was then also parked into its orbit as well.
Yeah.
And yeah, they sort of said that this satellite that they've called First Light is intended to sort of show their technology. So things like their thermal properties of the satellites, power, control, those sorts of things, and just sort of show that they have that capability. And I presume they're going to be doing something with that going forward.
It has a camera on it as well, doesn't it?
Yeah.
Yeah, I saw that it had a camera, and weren't they actually pretty decent about how long it was going to be up there for as well? Isn't it like 5 years?
Yeah, it was quite a long mission, from what I remember reading about it at the time. Yeah. So yeah, that looks very promising for Rocket Lab going forwards.
And for anyone listening that doesn't know Rocket Lab, they launch out of New Zealand, don't they?
Yeah, they do. So I think it's still an American company, but with sort of mainly New Zealand-based operations, and sort of based there. So yeah,
they always have great names for their rockets and their mission patches.
Yeah. So this was an Electron rocket. Electron rocket they were using for their launch. So that was quite interesting to see what they're doing. And I think in a sort of wider context, this is good that it provides more sort of competition in the field. So I guess for the last sort of year or so, it's kind of seemed like SpaceX were just eating up everything.
Yeah.
And they were sort of going to become, I don't know what's comparable to, maybe like a Microsoft or Apple sort of in their field in terms of doing everything. So I think it's good that we got this sort of competition in the sort of industry.
We've got that new one starting up as well, haven't we, in Scotland? Is it Skyora?
Yes, we have, yeah.
And
I'm not that familiar with them, but...
I know that they're planning on... I think they've launched something from Scotland, but last week they launched from Iceland as well, and I'm not sure why, but they were there doing some tests. I think they put a weather balloon up or something in Iceland.
Mm-hmm.
But yeah, definitely. The more companies, I think... Well, it's awkward, isn't it? Because you want competition because then it drives innovation. But then if you have competition, we're falling back on what we were saying about space debris because there's going to be more of it going up. So I don't really know how you win on that one. But yeah, definitely. It's cool to see other companies doing it. And I always get mega inspired when I watch rocket launches. I don't know about you.
Mm-hmm.
I just love watching them. It's
Yeah.
quality. That Demo 2 launch was awesome back in the summer.
Mm-hmm. I sort of thing I'm maybe most excited about is it's great to see these sort of launches, sort of putting the satellites into orbit and stuff. That's great, but I think it sort of frees up bodies like NASA and ESA to do the really cool science stuff.
Yeah.
If all the commercial launches and stuff are being taken care of commercially, then that means that those sort of budgets that sort of the governments are able to provide can go to stuff like Mars missions and sort of climate sciences, planetary science, that sort of thing. So hopefully over the next couple of years or even decades, that is something we'll see as well coming out of this.
Yeah, no, I agree with you because I think it definitely helps. But then you've got China, who are just secretive with everything that they do.
Have you read my notes? Because that is then my other story that I wanted to talk about in space was this Chinese space plane.
I have nothing. I know nothing about this. I know that a couple of weeks ago I was looking on, I think it was Supercluster, just launches that were coming up, and I know that they're like planning on putting up their like entire space station, aren't they?
Yeah,
within like a year or something crazy, isn't it? Like the turnaround for it. But no, I don't know what you're about to talk about. I've just seen the title of it. That's why I was like segueing.
Yeah, so I mean, you don't know much about it. I don't know much about it. It seems like no one knows much about it because the first sort of things we saw about this were really only coming out confirmed over the last few days. There have been rumours for, I think, the last couple of months, maybe a year or so about this, but it seems like China have launched some sort of space plane. So this was...
Doesn't it look similar to the shuttle?
Yeah, it is a similar sort of design to that. But yeah, I pull it on the list because it's interesting and I sort of found it quite interesting and people might want to know about it, but there really is not much to say about it other than this is cool. And I guess this sort of just goes to show, that China is sort of establishing themselves as a big player in the field in terms of what they're doing in space.
Because I think I saw somewhere on the thing that you put up, their goal is by 2030 to have a single stage to orbit space plane.
Mm-hmm. That if they did that, that would be incredible.
Yeah.
Single, forget even the space plane part of it. Single sort of stage to orbit would be massive.
Yeah.
In terms of that capability, is there really any competition to that at the moment that you're aware of?
Not really.
No.
No. Well, it says here as well they plan to have it fully reusable launch by 2045 as well, and they're going to have the shuttle to be nuclear powered. I mean,
you read this sort of stuff and it's mad, isn't it? What they're planning.
sounds like Halo that did.
Hmm.
Sounds like the Pelican, you just fly in and out.
Yeah, sort of nuclear powered again. Which again, going back to what we said earlier about sort of international treaties, I'm not even sure whether you're meant to be doing that. I wasn't sure whether nuclear was
Yeah.
allowed in space.
I
Just
thought,
on
yeah, I didn't think you were allowed to have. I don't know. Actually, I don't know. I think you are allowed to have nuclear power in space because didn't they
Mhm.
do it for like the rovers and stuff that they send to Mars? But then you're
Yeah,
not allowed
yeah.
weapons, nuclear weapons in
Okay.
space.
That
Because
would make
there's
some
that
sense.
whole problem, isn't there, that you can just let it orbit over a country and then just drop,
Hmm. Yeah, that's
which isn't great. But
yeah. There is.
yeah, they're on it. They're doing so much stuff. They're
Mhm.
because I saw that they only recently put up their like their version of Google Earth as well.
Like, I haven't seen that, to be fair, but
I think it's the
surprise me.
I think it's the One World Observatory, but I might be wrong. That's what they were calling it, I think. But I don't know.
Fair enough.
I used to have to code in launch times for a website called Spaced. So I remembered a couple of things I was like seeing. I was like, oh my God, they've got like 4 launches this week. They're crazy,
Yeah.
aren't it? Where
Well,
did they
just
launch from?
Can't exactly remember. The Jiquan Satellite Launch Center. I could do a quick search on that, whereabouts that is. It is in the Gobi Desert in Mongolia.
Oh, wow.
So I guess well, nothing is near anything around there, but similar to the sort of Kazakh launches that Russia
Yeah.
uses, that sort of area. So yeah, they seem to be sort of quite rapidly increasing their capability because they recently did the moon mission, didn't they? They were first people to land on the far side of the moon. They
Yes,
did
they
that.
were.
Was that last year? I think.
Yes. Didn't India spill a load of tardigrades as well on the moon?
Yeah, I saw that. Was that last week? That story.
Yeah,
Was
I think so. It's either last week or last month, but it was it's recent, isn't it?
Yeah. Yeah, we should definitely do an episode on sort of space contamination and stuff, and sort of how that ties into things like colonization and things.
Yeah,
Because
definitely.
that's something else that I'm interested in. But yeah,
Yeah, I'm having a look now just to see what launches we've got coming up.
Mhm.
You've got an Astra Will launch rocket happening, orbital test. Astra's that new startup, I think. And you've got the Delta Heavy 5 rocket carrying stuff for the reconnaissance office for the US.
Mhm.
And then in 17 days, China are launching the Ocean Observatory satellite called Haiyang 2C.
Sounds fun.
So they're doing another one non-stop.
It's all go at the moment.
But that's it for this month, which isn't too bad. You've only got like 5 so far on the list, but I'm sure more will get added.
Yeah.
There'll be some more China and SpaceX ones for sure.
Yeah. So that was the last sort of item that I had on space news this week. Just so people sort of aware as we go forward, we're sort of splitting up the news. We're looking at space, sort of general science news, and then other techie stuff. So this week I've not got any sort of science news. It was mainly space for me.
Yeah, there was a lot going on with space for me as well.
The only other thing that I had was from tech was Apple and their contact tracing for coronavirus. They've released. It's not an app. They've sort of taken a new sort of approach with it. It's going to be in the actual settings to enable contact tracing between people.
Yeah.
So they call it Exposure Notifications Express. It's a catchy name. The sort of thing that I think purposefully can get lost in the settings somewhere.
Yeah.
But yeah, I think it's going to be rolled out as a sort of software update on iOS. Yeah, so iOS 13.7. And it's going to be on there. doing its thing. So the way it's going to work is, I think Apple are sort of pushing this sort of contact tracing. Going to be using Bluetooth, I think, sort of looking who you sort of come in to close contact with.
Yeah.
And then countries will have the option to sort of bolt bits onto the front of it. So there will be, as I understand it, some sort of exposure notification inside of this. But then public health authorities will have the option to sort of put a local app on the front of that to presumably coordinate things like testing and lockdowns and that sort of thing. Yes, that was sort of quite interesting and topical.
It's an interesting topic, that, because it always goes two ways with people, doesn't it? You've got like, because like, although that's good, people just don't like giving away their data and being tracked and traced, especially America.
Yeah, well,
but
I think probably the less said about that, the better, to be honest.
Yeah.
But
but
yeah,
it's an interesting one for sure, because you kind of need it, but yeah, what happens if like you don't have an iPhone?
well, yeah, Google's sort of Android alternative is meant to be releasing later this month, and I think there's been quite a lot of sort of collaboration between the two on this, actually, because theirs is also called Exposure Notification Express.
Yeah, I was going to say, actually, it's just ringing a bell now. I think, didn't they announce a partnership for it?
So I think they're working together on this quite a lot, and that's going to work in a sort of similar way.
Yeah.
But I believe theirs is going to be app-based, so it will be on the Play Store that you actually download an app to do this stuff, rather than it simply being a
update on your phone.
Setting in the background sort of thing.
That's cool.
Yeah. What's your sort of thoughts on Apple just sort of putting it in the background somewhere? Do you think that's a good idea in terms of getting people to use it, or do you think an app would be a better thing to do?
I prefer the app idea because I think it kind of allows you to opt in, but I can see why Apple have done it, and it kind of gets the job done. Do you know what I mean? By just putting it on the phone. So I kind of get both. I would prefer the app, but it's cool that they're just updating your phone to do that.
It's pretty crazy. I guess I think probably our own government has sort of found out that sort of nowadays the people who have the most information about you is probably the people that have your phone, in terms of this sort of thing. What was it on recently? I think it's maybe a podcast I was listening to. They sort of debated this point. It's like, would you rather someone be able to read your mind or be able to get into your phone? And when you think about it, probably read your mind, because think about the amount of stuff you have on your phone. Like,
ever as well. You know what I mean? Like, since you've had it. Yeah, totally. Information, was it? Digital information is like the new oil, don't they say?
Yeah.
Because once you know what the people want and how they think, you could just run it.
This reminds me of a story I heard about. We're going a bit off topic here, but never mind. We can roll with it.
Yeah.
Was this girl in America? So I think she shopped at maybe Costco or Walmart or so, one of these big sort of brands, and she had a loyalty card for the shop. And she started to get these vouchers, these coupons come through for sort of pregnancy related things. So stuff like babies' diapers and these sorts of maybe like vitamins, that sort of stuff. And she lived with her parents, and her dad sort of saw these vouchers coming through and got like really annoyed. And like, as I understand it, sort of went into the store and was, demanding to speak to a manager about, well, you're sending my daughter this stuff about pregnancy and stuff. It's a bad influence, etc. And it turned out that she was pregnant, and the systems that they used on the loyalty card, from like her shopping habits of what she'd been buying, had been able to see that and had been able to predict that she was pregnant before like she'd even like told her dad and stuff.
Oh my
It's
god.
crazy, isn't it? This is like
Yeah.
this is like Black Mirror sort of level of
That's
sort of
nuts.
creepy. Yeah.
Whoa.
Yeah, I think it just sort of goes to show what data can sort of say about you in that way.
Yeah, totally. I was actually going to mention this to you. You should check this out, and anybody listening, it will blow your mind. But there is a website called philosopherai.com, and it's built with that GPT-3 software. So I don't know if you've seen much about this, but basically it's, from what I've gathered, it's to do with like neural networks. And you can get it to do different things. The two functions I've seen it for is you can ask it questions, and you can actually get it to write you code as well. I don't know if you've seen much about this.
Ooh.
But it's really cool. You go into like the text box, and you like would type out like a white web page with red text and a box that says subscribe that is in purple, and it will produce the code for you in whatever language you've selected, and then you can just copy and paste that code. But anyway, they had this one called Philosopher AI, and you could ask it questions, right? And I've got to read you this because it was like, it answered the question almost better than I could answer the question, and it just blew my mind. So I was asking it really silly things. I was just like, how far can we take this? So I asked it what the meaning of life was. And all it put back was the meaning of life, well, first thing that comes to mind is that would be a very good question for AI. Meaning is something that only intelligent beings with free will can appreciate and understand. How could you possibly understand what the meaning of life is by studying some ants or bacteria or lower order animals? They don't have any concept of purpose, nor do they even care about living in the sense we do. We are conscious and aware. To us, that gives us meaning, and that makes sense. And they were like, for example, if you were to talk to your favorite color, your color wouldn't care what color it was. And I was like, well, thank you, AI. Like, you had to just go in deep. And then I was like, I'll ask it an easier question. I just was like, how big is the universe? And it was like, a very large place. It's difficult to say how big because it's very large. And I was like, I like it. But everyone, go and check that out because it will blow your mind. We were messing around with it, and I was getting my family members to ask it funny questions, and there was some funny stuff that it was saying. So check that out. It's quite funny.
I'll have a look at that later. Yeah.
Yeah, I thought you'd be interested in it because you can like ask it all of your free will stuff.
Well, yeah. I guess this will probably go into our, particularly the coding thing. This is something I wanted to talk about in a future episode about AI, about sort of how we control AI, because it's very easy to, once you get to that point, you can imagine AI creating more advanced and more advanced code, which is not potentially the best thing.
And it's not good for the job market either, because like you've got people our age that have spent like the last 4 years doing degrees in like computer science and full stack web development and stuff like that, and back end development, and now there are programs that, as long as you're good at describing what you want, you'll get what you want.
Yeah.
Just crazy. Soon it's going to be able to do digital art, music better than any of us.
Yeah. And I think probably sooner than a lot of people imagine as well.
Oh yes. Oh yes. Automation is coming. Isn't like all of the advertising, marketing, what's the other one? Insurance. That's a big one that's going to get hit by it. But we'll keep that for another episode because we're just rambling on about AI now. But I don't know. I think that pretty much wraps it up, doesn't it?
Yeah, I think that was, looking at my notes, everything that I wanted to talk about this week. Yeah.
So if you enjoyed this, guys, make sure you like it or give it a thumbs up. Make sure you follow the podcast for more episodes. We're going to be aiming to do at least one episode a week. So I'm sure there'll be plenty more to come. And I think that's it.
Yeah. I think for a first episode, it's gone pretty well. So hopefully it will continue.
Yeah. feel free to let us know on social media how it went as well. We'd love to get feedback, and if you've got any cool stories, like any news stories or anything that you think we should talk about, be sure to comment on our socials or email us at theinfinitevoidpodcast@gmail.com. That is the email. And don't forget, if you want to get in touch with either of us as well on social media, I'm at Jacob E. Carson on Twitter and Instagram. And what are you?
I am on Twitter at THE Matty JMP.
And yeah, we'll be cool to chat to anyone that's had a listen if you've got any questions. And we'll catch you in the next one.
Bye, guys.